Welcome to the Explainer. Today, we're going to talk about a piece of software that didn't just change the game for architects and engineers, it literally built a whole new one. We are talking about Autodesk Revit, a tool that completely transformed how we design our buildings.
But to really get what makes it so special, let's start with a little mystery. Picture this. The year is 2006. An architect, Omar Selim, is using a standard drafting program. He goes to delete a door, and instead of just leaving a gaping hole, the wall magically heals itself. He copies a door, and the wall just knows to create an opening for it. You see, he was used to drawing simple, dumb lines on a screen. This was something else entirely. It was like the drawing itself understood what a building was.
And that right there, that is the key question. How can a piece of software possibly understand the difference between a door and a wall? Well, the answer pulls us away from the old idea of just drawing and throws us into a whole new way of thinking about design. Okay, let's dive in.
To understand the magic behind Revit, we first need to appreciate the massive leap it represents. This is all about the shift from just drawing lines to building with actual information. And this slide, well, it lays it all out perfectly. On the left, with the old way, you're basically a digital drafter. You're drawing lines that the computer sees as, well, just lines. A wall is just a rectangle. But on the right, with Revit, you become a virtual builder. You're placing an intelligent object that the software knows is a wall with all its real-world properties, like what it's made of, how thick it is, and how tall it is.
So this whole new way of working, it's powered by a philosophy called BIM, or Building Information Modeling. And you might think this is some brand new idea, but get this, the core concept has actually been around since the 1970s. It's the simple but powerful principle that you should build a project virtually before you ever build it physically.
The author of our source material, Omar Selim, he just puts it perfectly. You're not just drawing pictures of a building. No, you are literally constructing a data-rich, digital prototype, a virtual maquette that contains every single piece of information about the real thing.
So if BIM is the big idea, the philosophy, then Revit is one of the most powerful tools that actually brings it to life. And its biggest strength is kind of hidden right there in its name.
Yep, the name Revit is a clever little abbreviation of Revise Instantly. And I gotta tell you, this isn't just some catchy marketing slogan. It is the absolute engine that drives the software's incredible power. So what does that actually look like when you're using it?
Okay, so this is where that Revise Instantly power really clicks. See, everything in a Revit model is connected. It's all one living, breathing model. That means if you move a window in that 2D floor plan on the left, bam! It instantly and automatically moves in the 3D view, in the section view, and even in all the data schedules. It's all coming from one central source of truth.
This whole idea was so revolutionary. I mean, it was first coded way back in 1999 that the big software giant Autodesk scooped up the company in 2002 for, get this, $133 million. They knew this wasn't just another drawing tool. This was the future.
So, Revise Instantly sounds cool, but what does that actually mean when you're trying to build, say, a huge skyscraper or a complex hospital? Well, it means total coordination on a level that was pretty much impossible before. It completely flips the old workflow on its head. Instead of having architects and structural engineers and mechanical engineers all working on their own separate, disconnected drawings, nope. Now everybody's working on the exact same central model. And this lets the software do some truly amazing things, like automatically spotting where a pipe is about to smash right into a steel beam, a problem that could cost a fortune to fix on a real construction site.
And this is the real-world value right here. Finding those errors digitally means way less wasted material and labor on site. It's a huge money saver. It means better collaboration because everyone is literally in the same model, and it means unbelievable efficiency. The source author points out you can generate tons of detailed sections without the slightest effort. I mean, that's a total game changer.
You know, this massive shift from drawing dumb lines to modeling smart information, it's not just about a new tool. It's really about designing and constructing a better, more efficient future for the entire industry.
The author of our source guide, Omar Selim, gives some really powerful advice here. He's encouraging anyone in the field to just jump in, even if it's on a small project. Don't see it as a risk, but as a chance to get what he calls priceless experience.
And that really leaves us with a final big picture thought. This technology isn't just about making better drawings. It's about building smarter, safer, and more sustainable buildings. It makes you ask the question, if we could build a perfect digital twin of a building first and catch every single mistake before a single brick was ever laid,
What kind of world could we actually construct?